Good afternoon, students. Today we are going to discuss a topic called stack. Okay, it's one of the important concepts in data structures. So, what is the use of stack and why we have to go for stack and what is stack? We have to see. So, first of all, stack is a linear data structure. Stack is a linear data structure. We already discussed about the classification in the earlier class that data structures are classified into two categories. One is linear and another one is non-linear. So, array, stacks, queues and linked list comes under linear data structure. So, it has only one end. It has only one end where elements are going to be inserted and elements are going to be inserted delete. Okay. So generally each and every stack has only one end. Okay. Every stack will have some size. Every stack will have some size or some capacity. Some size or capacity to specify the number of elements or the number of items to be, the maximum number of items to be stored in them. So here each and every stack has only one end where the elements are going to be inserted in and deleted only from the same end. Okay. So every stack will have some size or capacity. So the capacity indicates the total number of items in the stack. So what is the maximum size? That means how many items you are going to put in the stack. That indicates the size of the stack. So initially, every stack will have a pointer called top. Every stack will have a pointer called top. Okay. So and stack follows last in first out principle. It follows last in first out principle. What is known as the last in first out principle? The last item that is inserted will be retrieved first. So simply we will call it as LIFO. Last in first out principle. So if you observe carefully, so every system will have a stack. Stack purpose is to store the items. The main purpose of stack is also used in function call, where the arguments that you are passing will be stored in the stack. So stack, but if you look at the stack, the operation of stack is, or the principle of the stack is last in first out. That means last inserted item will be first retrieved. Okay. So let us go with the operations of the stack. Okay. First of all, let us take the array implementation of the stack in Python. Array implementation. How can you implement in Python? Okay. Stack can be implemented in two ways. Stack can be implemented in two ways. One is using arrays or lists. Second one is using linked lists. Using arrays or using linked lists. So this is also called as static implementation. Why it is called static implementation? Because before going to implement the stack, we have to know the size of the stack. Okay. So this is called dynamic implementation. Dynamic implementation. Right. Generally, how stacks look like? So if you see the stack, for example, I am taking using lists. Okay, right. So let us consider this as a stack. Okay, what is the capacity? Suppose assume that 0, 1, 2, 3 is the letters of the stack. The address or index value. So items will be inserted like this. So what is the operation for insertion? Push. For example, let us assume that 71, 85, 63, 45. These are the items. Okay, what is the maximum capacity here? The size of the stack is 4. Okay. So here the list index starts from 0. Okay, initially top will be pointing to -1. So top will contains the value of top will be -1. Okay. So if you observe carefully, so initially the assume that okay, insertion operation is nothing but operations that we can perform on stack are push, pop, and P. So push means inserting an item into stack. Pop means deleting an item from the stack. And peek means retrieving the topmost item or retrieving the topmost item from stack, but not deleting, but not removing. Okay, so what are the different operations we can perform on stack? Push, pop, peek, and last one is display. Also we can do. Display means just to see what are the items that are present in the stack. Okay, so push means inserting an item into the stack, pop means deleting an item from the stack, peek means retrieving the topmost item from the stack, but not without removing it. Okay, so let us see all these operations by taking an empty stack. Okay, let us see the static implementation. Static implementation. Static implementation of stack using lists in Python. So what we need to take? First one, a list. Second one, size of the stack, size of maximum capacity of the stack. List size of maximum capacity of the stack. And next one is top point. Okay, let us take my stack as name as yes. So let us with capacity, maximum capacity, that means 0, 1, 2, 3, 4. Okay. So what is the initial value of top? Is equal to -1. Okay. So initially stack will be like this. So pop, push. So initially stack will be empty. So let us take the empty stack is like this. Empty stack. What is the stack name? Yes. Okay, initially this is called index of the list. Okay. So top will be pointing to this one. Okay. What is the maximum capacity of the stack? 5. So maximum capacity is size of the stack is 5. So that means you can store 5 elements. So how can you store? So you have to push, to insert or push. To insert or push 50. Okay. So how to push? So first of all we have to check whether the stack is empty or not, or stack is full or not. So how to check stack is full or not? If top is equal to max minus 1, then indicates that stack is full, we cannot insert. Yes, then we can insert. How can we insert? By incrementing the top pointer to value. Top equal to top plus 1, and then what we have to do? We have to insert in the stack. So stack name is S dot insert of top comma some x. X is the item you want to insert. Okay. So after inserting, how the stack looks like? 50. So this is called address. Top pointer will be pointing to this one. Okay, in the next class we will see the continuation of the remaining elements, how we have to push all the other elements.